Dear world, welcome back to this session. So previously we have understand everything, a lot of things about the tree. We have understood the basics of tree, the architecture, the normal terminology, and then in the last session we have understood all the types in very details. And that's now. So in today, in next session we'll be observing the tree representation, and we'll be starting today. Today's video we'll be mainly observing, we'll be analyzing the node architecture, that how we can represent the node in code Java program. So let's analyze, let's try to understand this node. So let's move to the nodes PPT. So that was the structure, the type of trees that we have done in previous session. So this is the architecture where we will be understanding the node. Let me remove this session. Okay, so let's start understanding the node. So we mainly work in trees, data structure. We mainly work with binary search tree. We mainly work with binary search tree. So how it looks? First, when we actually try to understand, the tree was like this, 1, and now in the left side there is 2, in the left side there is 3. So what is the actual architecture of this 1, 2, 3? We'll be understanding. We generally, this is called pictorial representation. That means, to understand for better clarity, we just represent like this. But how it's actually represented in computer, this is like this. This node breaks like this into three parts, and this is called the left part, the left side. This is the right, we call it right, and this middle one, this is called data part or node, whatever. So we'll be calling data in today's video. So now here one is assigned like this. In data part, one is stored. Now one points to another. Now two is also represented in a node. One, two, three. Those all the particular things is, those all particular things is are a different node, are a different node. So if you create another node 2, so this is like this, 2. So this is again the data part. This is 2 is stored in the data part. This is data part where 2 is stored. This is the left part, and that is the right part. So now if you draw the architecture of 3, so it goes like this. This is the left part, this is the right part, left, right, and this is the data part where 3 is stored. Now if you observe, we just drew a line from here like this. We just drew a normal line like this from, but what is it? That is actually not. Here it has a particular memory address. Every node in any programming language has that address. Let's call the address as 100. So this 100 address is stored in its left part. It is stored in this here, and only when that is stored in that place, then it points to this one, then it points to this node. Let's say this is having the memory address 200, and when this memory address is stored in here, this section, in the right pointer section, then only it points to this node. And let's say this is also having any memory address in the random 4599, the random memory address. So this is the actual architecture of any diagram, that they have a memory address, and that memory address, and they're linked by this memory address. So how we can understand? Okay, now we'll be understanding that how we can represent it into code. So now let's again represent this 1, 2, 3. So we are representing as the actual body architecture. So this is 1, and now there is again a node 2, and there is again a node 3. So what we do in the implementation, when we'll be implementing the entire tree, we will be creating all the relationships 2, 3. So while we try to create, we'll be trying to create all the relationship between all those by program. But in today's video, we'll be mainly understanding that how we can create this node, how we can actually create this node. In today, we'll be understanding this. Now notice this portion, this one. Let's zoom this. So that is that one. So this is one. One is stored here. We call this portion as data portion. Data portion. And there is already definition. It stores the value of the node. So whatever the value of the node will be stored in this position. This is called the left pointer. Pointer is what stores the memory address. left points to the left child, so it actually points to this left child, pointing to the left child, but it stores the memory address of the left child, so it stores the memory address of this child. So the pointer, so this is left pointer, and that is the right pointer. So how we actually create those pointers, that is the main thing. So first we create, to create any custom data structure. Suppose we want to create a custom data structure of this type. Here there is a lot of things, and suppose we say it, and we just demand that is, and we want to create that type of data structure. So we can create that type of data structure also in Java. But how? By only creating a custom class. To create any data structure type, we have to create a custom class. So for that, now we'll be creating custom class for our this representation. So let's create a class here. Class binary tree data. So we actually created a binary tree data class. Now we'll be declaring those three variables. This one data part. So what we store in the data portion, we store integer data 1, 2, 3. So we'll be writing like this: integer data, integer data. And in the left section and in the right section, we store memory address. What we store? Memory address of what? Of this same data type. So and that's why we have to create the references, we have to create pointers, and for that we'll be creating data type of this same class binary tree data. So binary tree data, and this is left for left position, and this is right for right. So now we declared, this declaration is done here. So after the declaration is done, what we need to initialize them. We need to initialize some, so that whenever we call this class, we get a reusable object, and for that we create constructor. We create constructor for instantly getting constructor, to instantly get usable objects. And how we create the constructor? We create the constructor by this same name, binary tree data. So let's write binary tree data. Okay, I'm writing this section, binary tree data. Sorry, why this is binary tree data? The name is not so much correct. Let's correct it into binary tree node. Binary tree node. Binary tree node. So binary tree node. Now we always pass the data value from us. So this invokes with integer data. Now we will be assigning this data to like this dot data, this dot data, that is equals to data. Left equals to right. We initialize the left and right with 0 null, initial value with 0 null, so that they don't point anyone. So now we created the constructor. After we created the constructor, we need to set the getter and setter also in Java. We set getter and setter in Java to get and set method instantly using the previous already declared get and set method. So for that we'll be creating get and set data. So first what we need to get this integer data. So let's create set data and get data method. So for that let's write public void. We are using public because we want to call it from anywhere from our class. So this is void public void set data, set data, integer data, and we just assign it like this dot data, that is equals to this dot data, and again public void set data. Now we need to get the data. So whenever we will be trying to get the data, we'll get the data of type integer. So public integer, only integer value will be returned as integer get data. Now we don't need to pass anything as we are trying to get data. So return data, we'll be returning only data from here. So this is how we can get the data. Not only we want to get the data, we want to get the pointers also. So declaring constructor for those portions. Public void public void set left and in left position we pass pointers of type binary tree node. So binary tree node, binary tree node left, left. Now we'll be assigning this dot left equals to left. Okay, that is done. This dot left equals to left. Now we'll be setting the, now we'll be getting the left side. So for that, public binary tree node, because the data is of type binary tree node. So binary tree node, public binary tree node get left, and we no need to pass anything. Get left, return left, return left. So now we setted the getter and setter for left position also. Now we'll be setting for the right, because we also have the right variable. So let's start setting for right position. Public void set right. Now we are setting the data of right position, and the data is again of binary tree node type, binary tree node right. And now we'll be assigning this dot right equals to right. So we created the setter. Now we'll be trying to get this right position data. Public void get right. Public, not void, the data is of the binary tree node. Public binary tree node get right. Get right. Now we try to get the right data. So just we'll be returning right. Return right. So now after we have declared all the variables and constructors and the getter setters, we created the node. So how we actually were recapping that how we created this node. This binary tree node. We call this node binary tree node in our Java file, binary tree node. So first we declared this left portion, we declared left and right. We declared left and right by binary tree left and binary tree right. Then this was the data where we store integer values. So we call it integer data. We call this integer data. After we did, we created a constructor. Constructor actually creates a reusable object, an object that we can instantly use. So to get instant reusable object, instant reusable objects, we created a constructor. And after creating the constructor, we set the getter and setters also, so that we can get the data and set the data anytime from any class as we require. So getter and setter to get and set the data, getter and setter to get and set the data. So this was the Java method in Java, that is how we can create the custom data, or we can create binary tree node data. Any type of data that you want to create, we can create. So in next session we'll be implementing this binary tree node. Here we understood the node, and in next session we'll be understanding the node. So I am just making one, I'm okay. VS Code, actually this is not open. So in next session we'll be observing the implementation. It first we'll be understanding here, and we'll be implementing in VS Code, and we will test that also. So okay, meeting in the next session. Stay connected. Thanks.